Hello friends, I welcome to you in your YouTube channel Physics and You. Today I am here to discuss a new video related to the wave function. Let's start the video. So what do you understand by concept wave function? I will give you the basic examples to understand the wave function. First example is the water wave. Suppose you want to measure the properties or characteristic of the water wave. How you can measure? You can only measure their characteristic by measuring the height of the water wave. At a different point of instant, it gives you the characteristic of the water wave. Similarly, by measuring the pressure in a medium at a different point of instant, give you the basic characteristic of the sound wave. Similarly, by measuring the amplitude of electric and amplitude of magnetic vector at a different point of instant, give you the basic idea about their characteristic of the electromagnetic wave. Similarly, question arise, which quantity help you to measure the characteristic of the matter wave? That matter wave which was introduced by the de Broglie in 1924 means whenever electron is moving, a wave is associated with that particle, and that quantity which characterize that matter wave is known as a wave function, and that wave function is represented as a term psi. In case of matter wave, the quantity that vary periodically is called as a wave function. That is simple line. Wave function generally describe the wave propagation of the particle, means whenever electron is moving, it may behave as a wave. Wave function is a complex valued function. Wave function is a function of space and time. Wave function has no direct physical interpretation, but the square of wave function have their significance because it measures the probability of finding the particle at that region at that point of instant. There will be a few characteristics of the wave function are there. That characteristic are: wave function must be finite, wave function must be continuous, wave function must be single value, wave function must be normalized. Similarly, derivative of wave function must be finite, derivative of wave function must be continuous, derivative of wave function must be single value. These are the few characteristics of the wave function. Let's discuss the each and single term one by one. So first is the wave function must be finite. What it means? It means that wave function gives you the unique value for the given instant of the time or space, means it should have a single value. It does not mean wave function is giving you the multiple values. It will be only one single unique value will be there for a wave function, and it will be finite. If you talk about the wave function must be continuous, what it means? You can check out in a diagram. Wave function, first wave function is continuous, but second wave function is showing a sudden jump in that function. That means that jump is not a continuous, so it is not expected. It is expected wave function should be a continuous in form. Normalize, wave function must be normalized. What it means? It means probability of finding the particle in that system is unity. That is the condition of the wave function must be normalized. When we talk about the physical significance of the wave function do not have any direct significance because it is a complex value function. That complex value function is represented by psi equals to a plus eta b. Complex conjugate of wave function is represented by psi star equals to a minus eta b. But square of that wave function have their significance because it measures the probability density of that particle in that region or in that system. If you like the video, hit on the subscribe button. Thank you very much. Have a nice day.